Hello, everybody. Nice to see you all. It's a pleasure to be here. My name is John Fuller, and I have been with Avalanche Studios, which then became Avalanche Studios Group, for 16 years, I think. Started out as a developer. I've been in many different roles, and right now I am one of the people that sort of thinks about our strategic direction when it comes to tech. It's great to see you all. Can I have a quick show of hands? How many people work with proprietary tech or their own engine? Wow, that's great. And I guess the opposite question is inevitable. How many people use commercial engines? Okay, so both. That's great to see, so a lot of interest. I am going to tell you a little bit about our history and where sort of the choices that led us to have our own tech, and some of the questions that have come up along the journey, along the way, and how we've navigated those questions and sort of how we think about some of the challenges that we have today. So, I'd like to start with a recap of the games that we've made and our sort of first 20 years of being in this business. Oops. So that is a quick look at some of our games, and as you'll see, we've been making them for a while, but we've also diverged into some unusual games that you might not have predicted from us early on. So why did we build our own tech? Well, early on, we had a very clear idea of the type of worlds that we wanted to build. And in fact, right at the start, Avalanche started out as a terrain sort of engine tech demo. And that heavily influenced the type of game that Avalanche was trying to sort of invent or produce to exploit this new tech. But very quickly then it became clear what types of things we wanted to build into the first game, Just Cause. So let's have a look at some of the unique needs that fed that. There were a lot of challenges that required very specialized technical solutions. And I guess that's the first thing that you need to consider. What are you trying to achieve? And do any of the things that you want to achieve require new tech or require something new? And I'll illustrate some of the decisions that other studios have made that sort of indicate those ideas. This was the list of things that you see here. At that stage was very daunting, big challenges with difficult technical mountains to climb. Nowadays, that's not the case. You all will recognize these, and many will have sort of worked through them, implemented solutions for them, and they're very well known today. The other aspect of those early games from Avalanche Studios is on the sandbox gameplay side. And those ones maybe are not quite as prevalent as open world games. So we definitely wanted to make a point of building, sometimes we call it sort of the unique Avalanche flavor, and it's going extra all in on systemic approaches to things, simulations, rule sets that sort of allow the player to explore, not just explore geographically and explore the world, but allow the player to explore mechanics, explore how mechanics work together, explore how mechanics like feed off the world, and so on. There's a nice anecdote. I was developer on Just Cause 2, and I worked a lot with physics. I implemented a monster truck. It was the first monster truck that we had. It was quite close to release. And the difference was we had cars with a single raycast per wheel, which was the way that we sampled the landscape. A monster truck has very different needs because it has to have a proper physical realization of the wheel, so it can do much more complex traversal and contact with other objects, and maybe even impart forces. So I did that. It took about 2 weeks. We shipped the game. A few months later, I was in the gym with a colleague, and his teenage son and his teenage son's friend were playing at the weekend. They were playing Just Cause 2, this was. And Andy said his son and the friend took the monster truck to the top of a hill, fired it down the mountain as quickly as possible. There was a lake at the bottom, and what they were trying to do was to see how far the monster truck would float out into the middle of the lake. And that was the competition that they had for a whole weekend. So I'm the developer of this feature, the monster truck. I've never pushed a monster truck out onto water. I don't even know if it floats. I'm not sure if the QA team has tested it, either the external sort of Square Enix QA team or our internal team. And that thing that has emerged from the combination of systems and the combination of physical models and so on has become a gameplay feature, a part of the reason that two players play that game. So that's some of the magic of sort of building on systemic approaches, looking for emergent behavior, and that's really what sort of what was the charm that attracted a lot of people to the Just Cause franchise. So that's a little bit about the things that drove us to sort of have a clear flavor to our games and a clear idea of what challenges that we wanted to solve, and equally important, how they would map to fun gameplay experiences for players. Let's look at some of the questions that you might be facing in deciding on an engine technology. So first off, is there a red thread that links your games? And if you think back to the video montage that I showed at the start, you'll see some very unusual candidates in there. Like, for example, there's a top-down vehicle shoot-'em-up called Renegade Ops. That was born out of a passion project that a few people in the company did. They took the engine, they used it in a way that it was sort of probably never meant to be used, took it to a playable state, and then it was super fun and we loved it, so it got turned into a project. But quite far away from the type of identity for which the technology was optimized. Similarly, the Hunter Call of the Wild was a very different type of game for us, much more slow-paced, a lot less action, but it has become like one of our most loved games and one of our most successful games in the studio. So you need to figure out what is the red thread, or what is the sort of identity that you have, and are you going to allow certain games or certain franchises to have them, and how much diversity you're going to permit. and how you manage that type of diversity. The second thing is, to what extent do you want to push barriers? To what extent is the experience that you're trying to bring new for players? And where does that newness or freshness come from? If it's in art direction or setting or characterization or storyline, those things may not impart a lot of requirements on your technology. But if it's in pushing new sort of fidelity in animation, you see some examples of games that have answered that question in the screenshots, answered that question and very definitely come up with a very clear idea of where it is that they push the boundary, which has resulted in major investments in being the first to ship that sort of technology or being the best version of that technology out there when the game ships. It's also easy to look at the game that you're working on right now, or maybe the set of games that you're working at in the studio right now. I feel it's also very important to look at not just industry trends, but sort of the trajectory of what your studio is aiming for. So we have had some, maybe not unusual, but we've had some interesting developments in the types of games and where they've led, particularly as we've got into self-publishing, publishing and financing our own games. And I don't think that I could have predicted them, say 6, 7, 8 years ago. Multiplayer is one of those. A lot of our games right now are building in co-op multiplayer, not competitive multiplayer. Also, live service. So a lot of our self-published games, particularly the Hunter series being the best example, we shipped them with somewhat cut down scope, and then we have very close contact with the community. And we've built a massive set of back-end services and sort of ways to capture what the community thinks about the game. And then we ask them to heavily influence the roadmap. So what features and what content we're going to develop for those games. And the Hunter Call of the Wild, for example, is a game that's been out for over 6 years and is still going strong. And I wouldn't have been able to predict that a long time ago. And it has a massive impact on how you work with technology sharing and also the types of features that you need to keep live service games going. So think about your trajectory. What sort of what direction, game after game, are your portfolio choices moving in? Be careful not to try to compete on all fronts. It's very easy to get tempted by the latest tech demo or the latest shiny hair shader or latest piece of technology. And some of them you will have to sort of decide how important they are for you, but many of them will be distractions. And there are enough constraints that are put on you for sort of exploiting the new hardware that's coming out and living up to your game director's grand vision and so on, without you having to sort of fantasize about other ones. So it's just as important to think about the things that you don't need to score 11 out of 10 on as it is to have a clear identity about the technical challenges that you do want to solve. And then finally, you should have a clear idea of what things you're optimizing for and what's feeding into your technology choices and your investments. But you should also make sure that all of the stakeholders around, particularly if you have an external publisher, are also fed into that. Both the things that you are investing in and the things that you're not investing in. So probably one of the most important aspects in our evolution from being a studio that maybe made 2 to 3 games at any one time to a studio that now has 7+ games in production or in live at any stage is the way that we thought about the mechanics of sharing. And for many years we adopted a typical model of building off the latest released AAA game engine. So let's say you would have had at one stage the Just Cause 3 engine and the Mad Max engine, releasing about the same time. They have different prioritizations. The team has done sort of different investments. And then the next game to sort of kick off has to look at, okay, what engines are available. And even if those have common ancestors, common parents, they diverge almost immediately, unless you work very, very hard to keep them in sync. And if you've worked in sort of publishers with lots of development houses, this will be second nature. You'll have experienced it firsthand. So that's a reasonably common traditional model. And we saw that that was unsustainable into the future. And we had to move to a structurally centralized technology base. And that kind of move comes with some very complicated trade-offs. I'll sort of talk to you about what the trade-offs are. I'm not going to go into massively deep technical detail, but I'm happy to talk about any of the specifics later on. Here are some of the learnings that we have had to try to navigate. First of all, do everything that you can to resolve conflicts at the point of authoring. I'm sure you've all heard this sort of, if you catch a bug very early, it costs X, and then if you let it go through the whole pipeline of testing, bug database, back to QA, it costs 10X or more. And there are a number of things that you can do to try to identify the conflicts at the point of authoring, but when you've got multiple different games or teams, and they're all using the same technology, they're all essentially writing, if they're developing, they're all writing potentially conflicting code. And we've put a lot of investment into tools and infrastructure to try to identify when that's happening and to try to get the original author of that code, who is the best person to be able to reconcile that conflict, to do it as early as possible. So if you think of a sort of ecosystem of, I'm working on my game, I'm checking in some code, and then I have an idea that, oh, hang on, there's a problem that's going to happen over there, and if we let it, it's going to go through several different steps, further and further away from the author, and become more and more costly. So that's an area that we've put a lot of time into, helping to catch it as early as possible. Huge savings to be had there. Reduced cost of integration by integrating more regularly. We have game teams that are live, so they've released, and that are integrating from our main line, our sort of main engine branch. We have a game that is in very early stage who integrates every day. And I don't have the answer to this, but the data that I can see tends to suggest that there's a net gain. So the more regularly you integrate, the less time overall in a month that you'll spend integrating. So there's some sort of compound effect that happens the longer you leave technology integrations, which is a bit weird, and I'm not sure that we fully understand it. And I sort of philosophically you feel that, okay, but each issue should take X to solve, but there's some sort of rot that sets in when they sit there together and wait to get solved and sort of have a compound effect. Next, make sure you have enough content to find bugs and incompatibility. It's not unusual that you've got a centralized branch, but it doesn't have the content that all of the games do. And therefore, the best place to try to find out the compatibility issues is by pushing the tech to a game team. And that's a common model. Let's develop this thing over there because they've got the best content to prove its correctness. But that also means that you've sort of lengthened the distance between some branches and other branches. So what we've tried to do is the opposite, bring some of the content back to where we have our centralized tech. We don't want to bring it back in a game-specific way, because that means that the cost of maintaining content that is very game-specific goes up and up and up. But we try to define sort of canonical content that as much as possible captures the most common use cases of as many of our games as possible. You see that the diagram on the right has both arrows going from this sort of central spine to game team branches, but it's also got arrows coming back. And that's a super important economy to look at. How do you manage the... and I firmly believe that game teams, particularly in order to sort of realize the things that they want and not have their features going into a queue and waiting for an engine team to develop that, I firmly believe that game teams need to be able to do development. They need to be able to prototype ideas. Maybe they need to be able to prototype tools to prove that something is a good idea. And that's a careful balance of trade-offs, of guidance, of maybe frameworks to allow them to do something but not go outside of the rules or the guidelines that you have for tools development. But when game teams do that development, it's very important how you handle bringing that tech back and making it shareable. So if you lose control of that picture, then you will see tech moving of its own accord through cherry picking from game team to game team. You'll see multiple different versions of essentially the same thing showing up, popping up. And that's something that we have had to actively manage. And then finally, and this is easy for me to say, we haven't had a massive one yet, but when you have sort of continuity breaks, like for example we had a big one in the move from DirectX 11 to DirectX 12, and we still have some games that are on DirectX 11 who couldn't upgrade, and that's essentially the point at which they had to lock off updates from our continued tech. And that might have seemed like a good idea at the time because the cost of that upgrade was massive, but we still see that there are things that we are doing in our tech right now that they also have to do, like new platforms or new features or tools improvements. And if we lock that off, then the only choice available is to repay that debt later. And the cost of these other things, new platforms and performance, is just as big in some cases. So they either have to repay that repay the debt, or they have to re-implement the stuff that we've already done in one branch somewhere else. And that's also a massive cost. Duplicated work that nobody likes. So this is probably maybe the most important slide in the presentation. It's some of the investments that we've done to try to make an ecosystem of development that allows not like Uber centralization in one central tech team where they're the only people that can develop features, but that allows a little bit like a distributed development team or an open source community that allows active development across the organization and then provides just enough structure, tool set, infrastructure, guidelines to allow it to be sustainable. Okay. So tools accessibility and usability is definitely one of the areas where the sort of out-of-the-box experience with commercial engines is very, very difficult to compete with, particularly the sort of vanilla experience. And I can tell you some of the considerations that we have wrestled with and that have been important to us, but we are still working on improving our tools. And that's an everlasting, it's an ongoing process. Often when you work with proprietary tech, you tend to start with runtime technology and you tend to sacrifice tools. Or at least you want to figure out what sort of functionality and what features you have, and then the next question is, okay, well, how do I expose that to content creators? But as a developer, it's really important for us to not, as a programmer, it's really important for us to not think about, like, of course you want architectural excellence and high performance and technological brilliance and elegance in your design as a programmer. I'm not saying they're not important, but the only metric that should or the most important metric that should speak to the thing that you've built is what the game teams are able to produce with it. Hopefully some of those considerations feed into that, but when it comes to runtime systems and when it comes to how you've exposed them, a lot of time getting close to the teams, observing what they're able to produce with it, will give you some very surprising answers sometimes. Having said that, one of the strengths of proprietary tech is that you can tailor your tools to specific use cases. And we do that, and we did it a huge amount more, say 4, 5, 6 years ago. But it's very important to keep control of that situation. So it's very easy for tools and pipelines to become unstable and inconsistent. One of the issues that we struggle with right now, for example, is we have a world editor, and you can jump into the game, like toggle playing the game in and out in the editor, but the game process is built into the editor process. So if the game crashes, the editor crashes. There are technological ways to extract that, but that's also, I don't think is an active decision that anybody made at any point. It's just something that we now are living with and trying to mitigate the damage of. But it's a good example of how something fairly innocuous can have a massive impact later on, particularly an impact on stability and consistency of the tools. I think, yep, accessibility and usability and UX is also a massive challenge. We've been looking at, and I don't have the answer, we experiment and we try different ways and we write documentation and then it goes out of date and then we invest in sort of early onboarding tutorials. So we experiment with a lot of things and I don't have the answer. Recently we've been looking at some interesting ways to help users get help through in-editor elements. So for example, in our engine sandboxes, to have some help signs on the wall and have text elements in the game with a direct link to some of the documentation or some videos that we've recorded again in the game world, and to allow them to navigate some of the information about how to use the tech and how to use the technology, maybe where it came from, as elements in the game. Somewhat gamify the documentation. That's one of the experiments that we've done. We've just started to look at how AI can help, and just after a brief look, we've done a couple of experiments. We're by no means deep in, but it looks like a very exciting area for how AI can help. Things like AI bots on Slack that can help capture questions and maybe suggest answers, and that can help generate documentation and update it, keep it up to date, and see which stuff is stale and maybe curate it. So again, I don't have all the answers there, but there are some exciting areas that we're looking into at the moment. You all know this, but more and more developers are schooled on commercial engines. So it's a consideration, and it can be a shift for new employees who've come fresh from school, or even new employees that have come from other games companies and are specifically used to the paradigms that they've used with commercial engines. So it's worth thinking about. It's worth figuring out how that transition happens. And it's also worth being very open and transparent about them and talk about the reasons why you have unusual paradigms, or you have something unique, and you sort of why it's there. Maybe not why it's necessary, but why you haven't had time to change it yet. And then also the same barrier to entry exists with outsourcing partners. So many outsourcing and co-dev partners are also schooled on commercial engines. In fact, if you ask an outsourcing partner to sort of do a project, many of them will say, well, I know how long it's going to take me using this commercial engine because we're used to it, we know it inside out, and you'll get a clear answer. But with a proprietary tech, they'll say, ooh, I don't know how long that's going to take, and they'll probably multiply it by some factor to cover the unknown and the risk about getting to know your technology and so on. So There are some things to think about when it comes to tools. This is maybe not the most exciting part of the presentation, and I presume that you're all in the technology track because you're interested in tech, and maybe many of you programmers. But it is one of the most important, in fact, it's a criteria that if you don't sort of own up to it and pay constant attention, it can sink you. Believe it or not, there are studios that are still starting up, new startups that are making their own engines. Poland, I think, first of all, it's lovely to be here. It's my first time at the conference, and I've had a great welcome, but I'm also very impressed by how many developers Poland has, and many of them with deep technological roots as well. I'm from Ireland originally, but I live in Sweden, and there are startups still happening, so in Sweden, that are very definitely trying to build their own tech that does something that no other tech out there does. So it's not a thing of the past yet. We have, just on the cost front, we also have resources centrally that coordinate our tech. We have, as I talked about, we don't want to move all of the programming resources and the development to a central team, because that reduces the ability for game teams to customize and to prototype and to adapt. But it's also important for us to have people on the game team that are engine experts. And in many of our infrastructure, many parts of our infrastructure, we open up access to our low-level components through a kind of GitHub repository where programmers on the game teams can take a library, change it, check it in, and deploy a new minor version or a new major version. And obviously, the lower level you get, and the more common the libraries are, the more process we have to put around that, and guidelines for documentation, and guidelines for release notes, and what type of, is it a breaking change, is it just a patch fix, and so on. But we want to actively encourage everybody to contribute to tech. And that does help ensure that there are some engine experts on the team. And I think that's really important for things like moving technology back from the team to your central engine branch, for moving technology from your central engine branch to the team, for doing integrations and so on. But it does affect your budget and your team size. I'll talk a little bit about availing of third-party technology in a moment, but it's obviously important when you're looking at cost. And finally, there are a lot of things that require development time, and measuring them and planning and budgeting for them explicitly can really help relieve the pressures that you will see, inevitably see as a developer of proprietary technology. Some of them are, these are kind of hidden costs, but trying to make them unhidden and try to guesstimate them and try to build them in. I've seen a lot of different models for like removal of tech debt, or sort of refactoring week, or a bunch of different experiments for how people try to build it into their workflow and build it into the way that the teams work. Find your own. But maintenance, just detecting errors. Something happens, and then someone needs to find out, where is it? Is it in a central thing? Is it in the content? Is it in a new feature, sort of a volatile feature that the game team has made? And obviously bug fixing. Just answering questions. So finding the people that are experts, domain experts in some area, and making sure that they're available to talk to someone who doesn't quite understand it. It's even more important when you want your game teams to contribute to and change and adapt central components. Then it's even more important to have someone who can talk about the architecture and the trade-offs and the assumptions that have gone into making it the way it is. And sometimes you'll see that those things will result in a game or developer wanting to go in a different direction than is the sort of mainline direction of the assumptions that a certain component has. And then you've got to sit down and think about design and think about how you reconcile those. And in some cases, the answer will be to the game developer, we don't want to do that. Because if you take us in that direction, we'll be stretched in too many directions. And that will we'll have to fork our technology, this component. And I talk about the teams sometimes, and I say, you know, if we've got 5 mission systems, and they all do different things, great. And we have, across the board, 4 people that are working on the tools around the mission systems. That's not a lot of resources for the quality and the polish of the tools per mission system. So if you can consolidate them, find one to rule them all, then we can put a lot more resources behind it and make the tooling a lot more professional. Yeah, some other hidden costs. Merging tech from teams. I talked about refactoring and removal of technical debt, and then just the process of integration. As I say, we do a lot to try to reduce that cost by finding the incompatibilities as early as possible. So buying tech components, I'm not going to go through them. There's a list of things on the right-hand side that we usually use to ensure that we're not forgetting any important aspects of external tech or third-party tech that we're going to take into our engine. And it's when you integrate third-party tech, it's important to remember that that's the start of a journey, and it's a journey with the technology, but it's often a journey with the partner as well. So find out about the company, find out what their plans are, what kind of support that they're going to give you. There are inevitable areas, just like if you built the tech yourself, there are inevitable areas of mismatch, and make sure that you have sort of a path to be able to resolve those things. Can you influence the tech choices that they make? Can you get the source code? And so on. So as I say, I've listed some of the aspects of evaluation that are often overlooked in favor of like the cool new functionality that maybe caught your attention in the first place. I'm not going to go into them now, as they can be pretty technical, but I'm happy to talk about any of them afterwards if you have a few questions. I've seen, in my many years in the games industry, I've seen a number, particularly recently, a number of interesting hybrid approaches that are not either commercial engine or proprietary engine. And I think it's worth mentioning them in the context of these sort of big choices that you're forced to make. Number one, I've put some sort of taglines on them. The Head Start, that is a company that uses a commercial engine to get up and running and then gradually replaces parts of it with their own innovation. And after a time, that becomes a form of proprietary technology. Sure, it was born of some major version of a commercial engine, but very quickly it becomes a proprietary technology. And then you're into the same territory as a lot of the considerations that we've just talked about. How do you maintain that? What do you do when a new major version of the original proprietary engine comes out? What's your succession plan? How do you handle integrations? How do you handle even minor updates from the commercial engine or the proprietary engine in this case? Buy some time, and that is use a commercial engine to release the first game, but at the same time build the thing you're really dreaming about building, which is sort of a parallel track. I know of one company that's doing that right now. Odd one out, and that is that you have a commercial engine for very different games. You have a stable of games, and most of them are the sort of employ this red thread that we talked about earlier. But you have one game, for whatever reason, that might be on a platform that's not supported by our technology, or it might be a very different genre. It might have a very unusual technical requirement, type of gameplay, and therefore you're prepared, in the interests of being able to do that project, you're prepared to have a part of your organization using that proprietary technology. We've done that a couple of times. We've developed a few mobile games, and our engine is not and never has been suitable for that. So in those situations, we were happy to use a tool that was more suited. And then finally, partial solution. And that is to use, I mean, I guess it's similar to the Head Start part, but your strategy is not to try to build the entire engine. Build on a base, look at the parts that you know I'm happy to outsource the development of these things, and then this chunk is going to be where we shine. And then focus on updates just to that part that you feel. And it could be world editor, or it could be pipelines, or it could be runtime systems. So there are a number of different hybrid approaches, and you might think they seem a little bit artificial, but I have developers in my head when I speak about each of them, and you can find them out there. So in summary, let's see what I've done. I've talked about our history, what has led us to some of the technology choices that we've made. I've talked about some of the investments that we've made recently, so the switch to a very specific form of technology sharing that allows us to collaborate on technology across the whole organization, not just uber centralization. And then I've talked about some of the considerations that we've had to carefully be aware of and manage. So in summary, there's no silver bullet, there's no perfect solution to what technology choice you should make. Every decision comes with pros and cons, and you have to understand those trade-offs. Focus on understanding your current and your future needs. What are you trying to build? What's important to you? Is it tech? Is it the game? Make a decision that feels right, and don't fall into the trap of constantly second-guessing it as soon as some new glitzy feature comes out somewhere. Give it a chance, a proper chance to succeed, and invest in it. Figure out how you're going to manage the limitations and the downsides. This is true of a lot more than tech. But choose something, it's the same for production methodologies. They all have pros and cons, but figure out what the downsides and the cons of the one that you've chosen are, and try to do a lot of thinking about how you can mitigate those. You can not allow them to be damaging or to be costly. And then finally, be transparent about why you made the decisions. If you're secretive about the trade-offs, if you're not upfront about them, then they will foster resentment or frustration or irritation with parts of your team or with external partners. And be open about those. Hopefully, you'll get most people understanding and on board for the ride and willing to collaborate and willing to contribute. So that's an important part of it. And with that, I will say good luck and have fun on your technological journey. Thank you.
We still have about 5 minutes for a question. So if you guys have any question, here's the microphone. Do we have any? Yes. But sorry, there is a mic.
That's okay. I can repeat the question. Yeah.
Okay. But you were first, right?
Oh.
Okay.
Hello. Okay. So you mentioned that we could ask questions about the middleware. So my question actually is working with proprietary tech as well here. So is there a lot of middleware out there? And what do you think that is middleware actually something that you see could be coming again a viable thing for games industry? Because what I've seen, at least in my history, is that middleware has kind of constantly been just going out and out and out, and either consolidated to game engines or people just saying, hey, we need to invent everything on our own.
That's a great question. I didn't talk about this, but I was a member of the original Havoc team that developed physics middleware. And in those days, the middleware industry was very young. It was a brand new thing, and in many cases it was met with a lot of suspicion. It had a boom, but then it had a period of massive sort of consolidation or monopolization. So a lot of these good middleware companies, high-tech companies, get swallowed up by a publisher or by someone that wants to guarantee the availability of that technology, or by a commercial engine. So when I look across our technology span right now, I mean, even in my head, I can pinpoint like 5 or 6 areas that are crying out for a good, game-tailored, highly performant, very sort of interoperable, easy to integrate piece of middleware. And in the absence of those, what we often do is look for something that can nearly do the job, fulfills a small portion of that. Maybe the tools are great, or they have one feature that's particularly complex. And then we move that in, and then we struggle for years with the lack of sort of quality or excellence in some of the other areas. So, I mean, if I was in a university and working in game tech, I would definitely be consider trying to identify some of those, start a company, and see if I can keep it small. And then, you know, I think that not just proprietary engine game teams, but also even commercial engine game teams would be like, yep, that's the best pathfinding technology that we have out there, or that GUI interface can do what none of the others can. So for sure, I think it's crying out for a big explosion in quality tech providers.
Could you speak a little to the composition of your development team? Like how many programmers, how much of that is tools? Do you have tools designers? Or maybe a technical writer for the documentation you mentioned?
Yep. Let's see. It varies hugely. Our game teams are vastly different sizes because we do games of different scope. Our central team is around the 40-45 mark. It has mostly programmers. There's a fairly big tools team, a big runtime systems team, a reasonably small graphics team, a developer services, which is kind of like DevOps and back-end systems like build tools and those sorts of things, and then like online back-end services like telemetry and player data and player like server hosting and those sorts of things. So they're the areas, the main areas. We have a couple of tech artists that work centrally. We've got a tech art director that help sort of understand and plot out a direction for like where those tools or where the technology and the tools should aim together. We have had a tech writer, but the tech writer's job was not to create content. It was to create the framework and the layout and educate as many of the developers and the tools creators as possible onto how to write good documentation and how to create tutorials and what the different types of information and knowledge sharing should be, and to help us sort of find some technical solutions for making sure that the information is always up to date and easily accessible and so on. So it wasn't a writing job, more so as a kind of the project was called Unified Documentation Strategy, and it was more about the ecosystem for knowledge sharing. Is that okay?
Yeah. I have lots more questions, but maybe
We can take it after.
Okay, one quick question, and we have to end.
Hi, I work at Frostbite, so most of the stuff that you described feels oddly familiar. And one particular thing which like I personally struggle with is that like you kind of touched on that when you said that there are like plenty of new graduates from schools who are educated in commercial engines. Mm-hmm. I like that euphemism. I'm stealing it. And like I personally sometimes find it to a degree offensive that they often demand that we ditch our own tech and switch to one of those engines. And I kind of view it as a bit of a this happens despite the transparency that you also touched upon, that we explain patiently why we pick our particular battles, why we do things a certain way and not another one.
Yep.
But like, it seems like there's like a kind of like a sociological issue to connect to those people, to to just basically persuade them that that this way makes sense. It's not some imaginary problems that we're solving. Like, I wonder if you're also struggling with that, and how do you cope with that?
Yeah. So, I mean, so one part of it is, the transparency that I talked about sort of hides a much larger investment that you have to make, but like I say, there is no technology. I mean, if you've used a commercial engine in a full AAA production, you'll know that there are certain points in that production where you have all of the same problems.
But the issue is that most of the people on our team have worked with those engines, have run into those problems, and are like wiser by the experience. But a lot of these people who complain haven't.
Yeah. So, first of all, it's important to sort of not necessarily walk people through 20 years of engine development and all of that stuff, but explain to them why you've made certain choices. Second of all, be a bit humble. Like I say, there is no right answer. There's only the answer that you've chosen, and the consequences of that, your understanding of the complexities of it, and then your ability to try to mitigate those. And in certain situations, we may have made the wrong choice, and it's important to be humble about that as well. It's also important, like, some of those concerns may be legit. Like, there are people coming in and they'll say, I can do this in another engine or in another technology. And this could be, I can be more creative in a certain area. And with any technology, you will always have areas that you've invested a lot in and that you've focused on trying to expand capabilities, and areas that you haven't. So no matter what you're talking about, that will be a thing, and it's a legitimate thing, and I don't get offended by it, and I don't get sort of frustrated by it. I would rather hear what are the types of capabilities that other people have experienced and that may be important to us providing the gameplay experience that we want to provide. What are they? And did we make a mistake in the distribution of investment that we've done? And what are our options to try to redress that? Okay, is there a sort of low-hanging fruit to partially redress it? Or do we have to really bring it up to the strategic level and say, no, this is an area that we really have to properly invest in? So, there's some legitimate thoughts behind those questions, and then there are some just education about what choices you made, and hopefully people, trust in you. The bigger the organization, the harder it is to find that trust. But I spend a lot of time having just personal conversations over coffees and trying to make sure that everybody understands that we're on the same team and we're in the situation that we're in, and there's no evil villain in a tower somewhere like deliberately trying to make your life hell with crappy tools.
Okay. Sorry, we have to end, but we will continue our discussion in 10 minutes.
Yeah, I can plug that. We have a panel of a number of developers that are going to talk about,
Thank you.
proprietary engines. Yeah.